right, folks. Okay. All right, folks. Welcome to day 15th, and let's do a little recap before we start the class today from yesterday's session. So we went ahead yesterday and learned a way of sending data from a child back to the parent. We already did. We already know how do we send the data from a parent to a child. Then we learned how to send the data from a child back to the parent. We also went over, did an example, and then we came back in here, applied the same concept back in here called handle add to cart reference, and I've created handle add to cart original, which is right on the parent component on app.js, and I have a product which is a child component. Every time a click is made in here, handle add on each of the cart items. I'm trying to listen to that event in the parent and then change the data from is in cart to from true to false. Okay, and you can see that this is where I'm changing. I'm getting the location of the object in the array by using an ID. In this case, I'm making it much simpler. I'm using the same ID as the index of the array, and then I set the array item is in cart from true. Whenever I do a set state, render function is triggered. Okay, when render function is triggered, every child component renders again, right? If the product component, every time the for loop goes, every time the render is triggered, for loop is generates the product component and places onto the parent of this div section. Okay, and we will try to understand what happens when I do add click item on the component. Okay, so if I go to my product, what I would do in here is I would just create a utility function. This is out of React. I'm just creating a utility function in here. I would create a new folder and I say utils. Utils are nothing but extra functions that can be used across the project for doing repetitive tasks. Okay, folks. So I'm creating just a util folder in here, and inside the util folder, I'm creating a new file called getColor.js. So I'm writing in a piece of logic in here. Every time I trigger this function, I get a new color. Okay, so I already wrote this function and I'll have it in here. So it just gives me a random function, hexadecimal random function every time I call this. It gives me a random value every time I call this function. I go back to products, I import this function in here. Utils.getColor. Okay, and give it a refresh, and this get color, I call it on the product, and I use the style object, style background color hyphen, and I call this object here. Okay, and you can see each time a product is rendered, I'm doing a little refresh in here. See what happens. The first card color is yellow. I do a refresh, and every time I get a different color in there, because each time a component renders, if you go to the product in here, each time this component renders, it gets me a random color. Okay, it's not just the same single color. To make it more clear, I would say to get a random color. Okay, so each time it would give me a random color. Is it clear? So anytime a render function is called, it gives me a random background color, and this is true across all the components in here. All right, folks. Now what I would do in here, let's just do a refresh and check this out. Yes, Vivek.
So those colors are coming from utils or something?
Yeah, I'm just generating a random function. Now let me show you what happens in here. Go to here, JSBin. So log. This is just plain vanilla JavaScript. and then I'm console.log and get a color and see this what happens. It just gives me a color value. And
Right.
each time I run, it just gives me a different color because I'm
So
using
only give
math.random. Yep.
it will give you okay 16. I just want to know how many colors it gonna give.
Oh, it's gonna
Um,
give 256 million colors.
56 million.
256 millions hexadecimal. So this color is in hexadecimal. Okay. So
Okay.
hexadecimal color. So each time you change one gradient, you get a different gradient in here. So you can get 256 million colors using just the gradient values. So this hexadecimal represents how much of red, how much of green, and how much of blue you can have it in a single color. And combination of all these colors would give you different color.
Okay. Okay, bro. Got it.
Okay, so let's go back to our code, and every time I do a refresh, it should get me a new color, right, folks? Every time a render function is triggered, it needs to get me a new color. That is the idea behind this random color. So I go ahead and only click the add button on the first card and see what happens. So I just click the first one. So if everything works in a real world scenario, ideal case, only the color of this guy should change because the render function is only called on this particular card, right? So I give it add and see what happens. Let me minimize this and you can see that what happens. I click the add button on the first item. Okay, you see how the remaining cards are also changing the colors. I would do the same thing on the second item, third item, fourth item. Think about this. I am just changing a simple element in here. You go ahead and inspect. Okay, I'm just changing the value of one single item in here and see how it's gonna change the entire entire values in here. Just take a look. Do you think this is efficient? Do that again. Expand, expand in here. I'm changing only the first from add to remove. So if I go back in here, if I show you this, guys, this is the add button in here, right, folks? So what I do is I click the add button in here, and this is just changing the remove, but a very inefficient way of rendering or repainting the whole DOM. Isn't it supposed to just render one particular element, only the div, and it's supposed to change this particular guy? So the render function should only be called on the component where the change is required, but it's rendering all the components, all the product components are receiving this change, which is not good. No, our application is very small. It's very tiny. In fact, it's not even small. It's tiny. Think about huge applications where you try to click on one button, your whole UI is trying to render, and that adds a lot of load onto the browser. Once your DOM has been put onto the browser, only if you need to change anything inside the DOM element, you only need to change that particular DOM. You don't go by changing everything. Okay, folks, am I clear on that?
Bro.
Yeah.
Okay, now this is an interview question. What do you do in React to optimize the renders? Now, when I mean optimize the renders, I mean that you have to call the render only when it is needed, right? The render is needed for the first component. The render is not needed for the second component, third component, and the rest of the components. I just need the render on the first component. So I should ask the other components to stop rendering. Okay, folks, I have to ask the other components to stop rendering. And how do I do that? I have to tell the component I have to add in a logic inside the component saying, hey, component, listen, what is changing on the initial render versus the every time I click. Let's take one simple component. Let's just take one simple component. Click on inspect. Okay, components, and see what is changing on the component, on the props, that is making the component to render. Because a component renders only in two situations: if the set state happens internally, or it receives a new properties than the initial properties. Okay, folks, you send the properties that are the initial properties, which are this case, these guys in here. In this case, the initial properties is in cart is true. Let me remove that guy from is in cart. So the initial properties of this component are ID, image, is in cart, false. Let's see what are the second time when I press the add button in here, you get the second set of properties. So what the second set of properties are, the only difference is that the initial set of properties have is in cart false. The second set of properties have is in cart true. That is the only difference, right, folks?
Right.
Right? There's no. So if you take the second component in here, let's see what is the difference. If you take the second component in here, and I only change the first component, and let's see what happens on the second component. Do you think anything would change on the second component if I click something on the first component?
Is in cart maybe.
Does it? Do you think is in cart will change to true?
I think so, since when I
I'm not clicking on broccoli. I'm clicking on only walnuts, and this is broccoli.
That's why only UI is rendering, right? The flag is changing.
yeah, I think so.
Yeah, the ease in cart is only changing for the first one. Let's see if it's changing for the second one as well when I click on the first one. So I'm just clicking on the first one. Focus in here. I'm just clicking on the first one, and I have selected the second product in here. So I'm just clicking on the first one, and see, the second one is not getting any change, and it should not get any change. That is the idea behind, right, adding to the cart. You add only one item to the cart, and the next item should not have any difference in it. When I click on the second item, that should change. When I click on the third item, that should change again, right? So what I have to do is I have to throw in a logic saying, let's get this the baseline straight. A component renders in two scenarios. If the set state happens internally, okay, if the set state happens internally, or a component receives a new set of properties. Okay, folks, does it make sense?
One more time, bro.
Yeah, a component will only render when I say component, the product component will only render in two scenarios. Not just the product component, any React component will be rendered is render function will only be called only twice, only in two scenarios. Whenever you do a set state, okay, whenever you do a set state internal to the component, whenever the component undergoes a different state, doing a set state, the render function is triggered. The second scenario is whenever the component receives a new set of properties. Okay, when I mean new set of properties, when it first initially rendered for the product, is in cart is false. But the second time when it is rendered again, when it is rendering, because the properties have been changed. The properties have been changed from is in cart false to is in cart true. But that component, the properties are only being changed on the first, the properties are only changed on the first iteration of the product. They are not changed on the second component. Whichever the component you are clicking, only that component properties will be changed. So for example, I'm clicking, this is the third component in here. So I'm clicking add in here, and you can see is it changed from is in cart false to true only will be rendered if the initial set of properties change or the component receives a new set of properties. Okay, I'll slow it down a little. Imagine a component is nothing but a painting. Okay, a component is nothing but a painting, and browser is a wall. Okay, folks. Component is a painting, browser is a wall, and React is a painter. He paints the component and put it on the wall. He'll put it on the wall. Okay.
Yeah.
Now the React painter will only change the painting in two scenarios. Okay, let's take the real world example. If the painting on the wall is disturbed internally, okay, it's disturbed internally. There might be a spill, there might be a nail going rust, a nail may be rusting, or the wooden frame might be broken, something. A painting being destroyed internally, or painting being destroyed externally by might be a fire, somebody spilled a liquid, etc. So this painter will only repaint the painting either of these scenarios, right? Do you understand this?
Mm-hmm.
Okay. Painting get destroyed internally is state, which is internal to the component. React will paint it again if the painting is destroyed internally, or the React will paint the painting if something is disturbed externally, mean properties.
Mm.
Okay, so if the painting is destroyed by the external environmental condition, then the render will start repainting the painting. Okay, now apply the same thing to a component. A component renders. When I say render, it will recreate on the browser only in two different scenarios. If the component has an internal state change, name color is equal to orange, then I set the state from color orange to red. Now that is a state change. Now whenever I call a set state, a component renders. Or if the component receives a property from the parent to the child has been changed. Initially, I send a property name Arjun, and then after some time, I send another property with the same key value, name Vivek. The first time, it's obviously I have to render. The second time, the property has been changed. That is the reason it's rendering. But React components are not smart enough to understand if they are getting the same property or if they are getting a different property. That is the reason React is undergoing complete re-render again and again. In the first case, in the first product, you can see there is a property that has been changed. When I click on add, the property has been changed from false to true. But the second product, when I click on the first product, the second product does not care about the change. But it's still rendering. It's thinking that, hey, I'm getting a new set of properties. Should I render or do not render? It does not know about it. Okay. Mm-hmm. And we need to add this smartness to the component because we need to save the render. We don't want to load the components again and again and again. If the component needs a render, then it will render. If doesn't need a render, it doesn't render. How does it knows that the component should render or should not render? So we go ahead and use a very important component lifecycle in React. And this is if used, I have seen a project where I was put into a project. There were like thousands and thousands of markers on a map. Okay, if you are into Google Maps, there are little destination from where did you start to the destination, there's a little markers on the Google map. There were literally thousands of these markers on the Google map. You click on one of the marker, all the thousands and thousands of markers used to render, and the screen would go the browser would go crazy, crash, and then you will not be able to the browser is not responsive at all, because you're clicking on one marker but you're rendering thousands and thousands of marker again and again and again. So what we do is we go and tell other markers, hey, I'm only clicking on this marker. Do not change or do not re-render if the clicked marker is not you. Okay, so we add the smartness into this component, and that smartness is achieved by a component lifecycle called ShouldComponentUpdate. Now, plain English language, I mean, like, it's asking me, should the component update? Should component update? And what I do is I simply say return false. Okay, and I simply say return false. Now this is like a brute forcing the component. No matter if the set state happen, it receives a new props, it will never re-render again. Let's see what's going on. If I give it a refresh, okay, and do an inspect and go to the console, go to the components, click on one of the component and see what happens if I click on the add button. Previously it worked seamlessly, and now I click on the add button and see what happens. It's not working anymore because I asked the component to stop rendering. I throw in a component lifecycle saying should component update, and I simply said do not render by any means. Do not render. Forget about rendering. Okay, let's go to the official documentation of React and ShouldComponentUpdate and learn more about it.
That method is within the React, no? Something like component did mount component.
Exactly. And you know what, guys? We enter into the second phase of component lifecycle. This is called updating. We talked about initialization phase. Now we are talking about updating the phase, updating the component. Okay. For some reason this is not rendering, so let's go back. Now I'm just telling the component to stop rendering no matter what, but this is not how UI should work, right? My UI should be functional. Now unlike other component lifecycles, this component lifecycle receives two arguments. Those are new props, comma, new state. Okay, we'll just talk about new props for now. And let's see. And I'm just throwing in a debugger in here and inspect and add and throw in a debugger. Now this is where it's getting where it gets little complex. We'll go step by step. Now should component update is called on the initial render?
Initial render, no.
Exactly, it's not called on the initial render. It's called on the subsequent renders. The first time when the component loads, this is not an initialization component lifecycle. This is updating. Once your component has been loaded, you want to update the component, and that's where it kicks off. So the component lifecycle is never triggered on the initial render. Okay, anything, if the component undergoes a change, that's where it started rendering. Now I said new props. Okay, I said new props, but check this out. I'll just console login here. I have new props in here. Inside my new props, you can see that is in cart is true, but I also have access to the old props. The old props are this dot props. In my old props, does not have is in cart. So when the component first rendered, I send a properties which says is in cart false. Then I went ahead, click on the add button. The component received new properties. Okay. So what is the difference between the old property and the new property?
Is in cart.
Is in cart. So I should put in a business logic inside this component lifecycle saying if your previous if your is in cart is previously true and now it is true, do not render. But if your properties have been if your is in cart in false and false, then avoid rendering. What I mean by that is if next props dot is in cart is not equal to double equal to this dot props dot is in cart, then now you guys tell me, should I return, I'm sorry, new props, not next props. Should I return true or false? In this case, should the component render or should not render?
Should render.
It should render, right? So return true. Else
False.
return false. And
We
then
don't need that else now, bro. You said.
exactly, man. That is absolutely true. We don't need that else at all. Awesome. Now let's see what happens. I have to turn off my Wi-Fi. This is a problem because my network tab, products pending, got it. So turn it off, turn it on. Okay, I'm back again. Give it a refresh. And now let's throw in a debugger in here and then go try to inspect and see. I will throw, this is the first component. Okay, this is the first component that I'm dealing with. Is new in props, is no in props. So I go and see, okay, looks like it's entering into reflow. Okay, and now I go back and this is the second time iteration, and the second time iteration is for broccoli, and the broccoli, let's see if it's going into the loop. It's not going into the loop, and we can close this guy out in here and then do a refresh and now check the colors. What happens? I will also throw inspect in here so you guys can see what's going on. Right in here, you got all the products. Okay, and let's see what happens. I just clicked on, let me take off the debugger in here. That's not in my way. Elements and see what happens. As soon as I click on add to cart on the first item, only the first item is rendered. It does not disturb any of the components below it. Because this is a reusable component, a reusable component has its own conditions. If the properties change, it should render. But I should explicitly tell which properties should be changed. If an ID is changed, will the component render or does not render according to our logic? If the ID
doesn't.
it does not render because we only care about is in cart or not. And this is how you optimize the renders in React. This is a very important interview question. And you know what? I brought up this application from the flashing screens, browser not responding, by just inserting 3 lines of code. Just by inserting these 3 lines of code, I mean like these 3 lines of code in here. I just put in 3 lines of code and that brought in application and become very responsive. This is how you optimize your React components. Any questions in here? All right, so let me put back this guy. So I check in and should component update. Now, this is all good. Now, in recent times, I mean, like as React was evolving and everybody started doing more and more of the should component update. Now, React team decided, hey, you know what? Developers are not unknowingly or knowingly, or they not know how to use a should component update. Now, let's do this. Instead of asking the developer to add in a new component lifecycle, which a lot of us are not familiar with, they started adding something called a pure component in React. Okay, a pure component. Now, a pure component in React is nothing but it's the same React component, but should component update is done internally by the React library. So you don't have to worry about if your properties are changing or not changing. So I remove all these lines of code and I only added 4 characters. Instead of component, I added pure component. Okay, I just said pure component, and let's see if the UI is still intact with this change. And I go back, refresh, and as per the logic, the pure component should handle the change internally, even though there is no should component update. Okay, and I click on the first button, and magically it just handles the component. It will compare your previous props and your new props. Only if there is a change, then the component renders. If there is no change, the component does not render. Let's give that a try again. I'll remove the pure component from here and refresh and hit on the add on the first component, and that is changing all of the components. Go back, put the pure component, and done. As simple as that. You don't have to worry about adding all the logics all by yourself. And there is a limitation on how much deep the component object can compare. It does the shallow compare, but it's always a good idea to always go with should component update, where you have more control over the rendering cycle. Now the pure component, it doesn't or does not. It depends on how nested is your object. If your object is more nested, it does not do a real comparison. It just choose the shallow comparison, just compares object references and all that stuff. If you really need, if you want to squeeze the last drop of performance from the React, go ahead and use the should component update. But if you only have one property that is changing, in which in our case is just one little property that is changing, rather using a should component update and adding more lines of code, I would go ahead and use a pure component. Okay, now the interview question is like this: what is the difference between a regular component versus a pure component? My answer is something like this: a regular component renders irrespective of the props change or do not change. It does not care if the properties change or do not change. It simply renders. I have to add an additional component lifecycle called should component update to stop the render if it's not required. But if a pure component is there, a pure component handles the property changes without the should component lifecycle in it. Okay, the only difference is the pure component does not have should component update, but has the functionality of the should component update. A regular component does not have the should component update, but if you keep it should component update, it respects. Okay. And the follow-up question is, when do you use a pure component versus a regular component? If the properties that are sent into the component are nested heavily, I would use a should component update because I would have more control over the render cycle depending on my logic, I can either return true or false. So I would have more control over the render. A pure component does not do it does not do deep equality. It only does shallow comparison. It just compares on a high level. It doesn't go deep into the object. In this case, where the properties are plain one level, then I would go use a pure component. All right, folks. All right, so let's get started doing another type of component in React, which is used widely across in React projects these days. It has started doing from ES6, and we call that as a functional component. Now this is a class component. Okay, this is a class component. Let's do a functional component. What I do is I would just comment out the whole piece of code in here until all the way, and I would not render anything, but I would only create a functional component. A functional component, let's do this, and you would find it very simple. You might be asking, Vikram, why didn't you tell us at the beginning of the class? Let's do that. Constant product is equal to, okay, I can either use a function keyword or I can use an arrow function, as simple as that. And then return whatever I am getting it. Let's do just the h1 tag, and this is product, and then h1. Look, this is a React component. Can you believe that? As simple as that. Creating a variable, this can be a function as well. You really don't have to do this. This can be a function returning a view, and this is a React component. As simple as that. This is called a functional component because using the word called function, and this is a class component. And in a minute, we will see what is the difference between a class component versus a functional component. Okay. Now I'll try to recreate the whole class component in here as a functional component, and we'll talk about what are the major differences between a functional component versus a class component, and when do you use one over the other. And I think you would able to tell me when did you use one over the other once I start completing it. Okay, so what I do is right after the return, instead of returning a h1 tag, I return everything that is being returned from the this guy here. So return everything from here as it is. Okay, and before the return, I'm doing some component logic, which is this guy in here. Let label, copy over all of this stuff, and just give it a save, and that will immediately throw me an error. And let's see why does it throw me an error. And give to it, and oops, it actually threw me on the UI. Cannot read props of undefined. Product 13 line.
Okay.
Product line number 13. Guys, a functional component does not have this. Okay, a functional component does not have this inside it. Okay, so but instead we pass the props. Hey Mukesh.
Hi, hi Vikram.
Yeah, Mukesh, just hold on for another 10-20 minutes. We'll talk about it. Okay.
Yeah, sure. Thank you.
Okay. So a functional component does not have this inside it. Okay, so I go ahead and remove this, but like, you know, a function can be called using the arguments. A functional component, props are passed as an arguments to this function. So props, and I can complete, if I throw in a debugger in here and see what are inside my props. and see what is inside the props. Props are that are sent into this component. Okay, so instead of this dot props, I can simply say props. So if you can take a closer look, props have name, price, and image. So instead of this dot props, I can just say props dot is in cart. Go back. Instead of this, I say take it off this. Okay, and then give it a save. And that is giving us another error that says handle add of undefined, because we did not add the handle add in back in here. Where is that? This guy in here. But we would have props dot. What I'm trying to do in here is a handle add function in here. So I'll go ahead and copy this directly on the top. And this is not coming from the props. Okay, this is right inside the component. So I don't have to give this handle add, which is this guy in here, and instead of this I would say props. Okay, and you have to use a keyword called function in here, because this is no longer a no longer a class component. A class, and inside a class component, it actually knows that whenever I give any function, it actually knows this is a function inside a class. But this is a functional component. A functional component does not know that this is a method. So I have to explicitly call in the function keyword. Give it a save.
There is one more this referring in the function.
Oh, okay, got it. What's going on? Not returning anything. Just give me a minute. System is like going crazy in the browser. You close the browser. So we are back again, and you should able to see my component. I just converted my class-based component. So I don't have this fancy keywords, class, extends, pure component, all that stuff. I just created a JavaScript function, and that is returning a component. And I can go and write all my logic that belongs to that component right in here. Okay, makes sense? This is just the functional component. And you might ask a question, why do I need a functional component versus a class-based component? Now then, in theory, it's not proven. In theory, a class-based component takes more memory than a functional component. Okay, this is another trick on optimization. A class, you're creating a class. Anytime you create a class, you're basically creating all the component life cycles. Even though you're not writing any component life cycles, the React would create all the component lifecycle methods, and you inherently creating more memory on the browser. You're using up the more memory on the browser. A functional component does not have any component life cycles. It only has one component life cycle, which is render. That render, you do not see it in here, because that render function is the actual function that is returning it. So the interview question is, when do you use a functional component versus a class-based component? One liner. If I do not need any component life cycles, I would use a functional component. If I need all the component life cycles, I would use a class-based component until React 16 There was another point. If I do not need a state, I use a functional component, because you cannot create a state in here. If there is no constructor, you cannot literally create a state in here, right? There's no state. There is no this, in fact. If you have to set a state, you have to say this dot set state. There is no this inside a functional component. But starting from React hooks, which is 16.6, I believe, or 16, I will, React 16, you can create a state inside the functional component, and we will talk at the end of the course how do we do this. And now there is another problem, guys. If I give it a refresh, Arjun, why did we put the should component update?
Should component update. If you don't want a whole UI to render, instead only one particular component that we need to render.
Right, so we used a class-based component and we used a should component update only to render that component. Then
Right.
we took that out and we used a pure component. But what happens when I use a functional component? And let's see what happens. If I give it a refresh and do an add, oh,
Same thing.
yeah, that is bringing back the same problem. So if they are introducing a functional component, they need to introduce something that should optimize the render. And then they came up with something interesting. It's called React.Memo. Simple. Just wrap your, I'm putting this back using the ES6 syntax, okay? So just make sure I'm just using an ES6 syntax in here that makes the code a lot easy to read and less keywords to use up. And inside which I would pass the props, and that props will be rendered and add. And anytime I add, the colors of the other components are changing. I want to make not to change them. So I use something called React.Memo, M-E-M-O. And I wrap the entire component using React.Memo and give it a save and add. And you see the problem is solved. The React.Memo, which is memorize, it memorizes if your previous props and the new props are the same, then it will not go through another render. If the previous props and the new props are different, then it will go through another render. Did I mix up? If the props are same, no render. If the props are different, go another render. So if the interviewer asks you this question about trying to confuse between when do you use a class-based component versus a regular component versus a pure component, then a pure component versus a functional component versus React.Memo, you should have a very good understanding of each of this and where they are used. So I would, I would break down that into, let me just, okay guys, check this out. If I need a React component, I either take left or I take right. When do I take left? If I need a state, when the state is required when performing network operations or storing the user data, all that stuff, I would go create a state component. Then I would decide again, if I want to create a state component, do I need to render it or do not render it, depending on the props change. Then I decide, okay, no matter if the props change or do not change, it has to go through another render. I would go create React.Component. No, I care about performance. I need the performance. Then I would go add a ShouldComponentUpdate inside the React.Component, or I would use a pure component. Okay, if I'm taking a left route. If I'm taking a right route, I don't need a state. I don't need any component lifecycles. For now, React hooks introduced a state inside the stateless components. And oh, I missed to tell you, this functional component has different names. It's called ES6 stateless components, or presentational components. I should say component. It's called a presentation component, or a dumb component, or a functional component. All of these names for the same type of component. Everything goes to the same function component that we just talked about. A class-based component also have two different names. It's called class component or a smart component, because it has all the component lifecycle state and all that stuff. So people say it's a smart component because it understands the state, it can make the network calls, it can go get the data and all that stuff. Now, if I have to decide if it's a stateless component for now, just for now, I'm not considering the React hooks, then I would go using a functional component. If I need to render, if I have to optimize the render cycle, then I would go use a React.Memo or functional component. Am I clear on this?
Yes, bro. To me.
Yeah. Yeah.